Every few Earth months, Mars, the once slumbering red planet, emits a mysterious belch that reverberates through the chambers of space agencies worldwide. This is not a poetic metaphor for a celestial event, but a scientific observation of methane burps, which the NASA Curiosity rover has detected sporadically wafting through the thin Martian atmosphere. What might appear as trivial gas emissions to the layperson carries profound implications. Methane on Earth is predominantly produced by biological processes. Could Mars, against the stark barrenness visible to every orbiting satellite and rover, be suggesting a hidden biological narrative beneath its rust-colored dunes? The enigma of Martian methane first gained prominence when NASA's Curiosity rover, trundling through the Martian soil in Gale Crater, recorded intermittent spikes in methane concentrations. These discoveries, made via an onboard laboratory known as the Tunable Laser Spectrometer, upended preconceived notions about the barren planet. On Earth, methane is overwhelmingly released by biological organisms, but can also be generated through geological processes such as serpentinization, raising the fascinating dual possibility of life or unique Martian geology at play. Much like a detective piecing together disparate clues, Curiosity's ongoing mission involves not only periodic sniffing of the atmosphere but also analyzing soil and rock samples. These measurements are critical in mapping the methane emissions over time and correlating them with other atmospheric or soil conditions. Laboratories on Earth have long studied meteorite samples from Mars, revealing the presence of reduced carbon compounds, possibly explaining some of the source of methane. However, the sporadic nature and localized concentrations of methane detections suggest dynamic processes are at play, which these inert meteorite samples cannot fully illustrate. As scientists probe the origins of Martian methane, two primary hypotheses have emerged: biological and geological. The biological hypothesis tantalizes the public and scientific community alike, suggesting that microbes could be surviving in subsurface niches, metabolizing and releasing methane. This hypothesis leans on analogs found in extreme Earth environments where life teeters on the edge of possibility. Alternatively, the geological hypothesis suggests that the interaction of water with olivine, a mineral abundant in Martian crust, could be producing methane through a chemical reaction known as serpentinization, a process well documented on Earth, particularly in its early, less oxygenated eras. The pursuit to pinpoint the exact origins of these emissions has spurred innovations in technology and methodologies. Surface missions, orbiter-based observations, and even proposals for drilling technologies to sample the Martian subsurface directly aim to solve this planetary puzzle. Moreover, spectroscopic analyses from orbiting satellites provide complementary data, mapping methane's temporal and spatial variability against Martian seasons and surface features. This multidimensional approach not only sheds light on the methane mystery but also enhances our understanding of Mars' geology and climate systems. The implications of Martian methane extend far beyond the novelty of extraterrestrial gas. If the biological origin is confirmed, it signals the possibility of life, albeit microbial, beyond Earth, which fundamentally shifts our understanding of life's robustness and distribution in the universe. This would not only galvanize missions to Mars, but also bolster the search for life on other planetary bodies. On the geological front, understanding Martian methane emissions could reveal much about Mars's past climate conditions, geological activity, and even potential for past life-supporting environments. This knowledge is crucial as it shapes the strategies for future human missions, including the selection of landing sites that offer scientific value and safety. Each methane measurement, each data point Curiosity sends back, sews another stitch in the vast tapestry of Martian science. As technology advances and new missions touch down on the Martian surface, the mysteries of methane might not only unfold a story of geological wonder, but perhaps introduce the first chapter in the discovery of Martian life.